So let's take a look at just one more technique. And you don't need this technique very often. When we use this technique is when we have a quadratic function involved in the integrand, meaning we're trying to take the integral of a quadratic, and sometimes we want things to just work out a little bit nicer than they do. So just a reminder from way back in the day when you first learned how to complete the square. Essentially what we're going to do is we're going to try to rewrite our function as a difference of two squares. So what I would typically do is take the x squared plus bx, and I would do plus blank, and then I would do plus the c that's given to me plus blank, sorry, minus blank, because whatever I add here, I have to subtract here, so I'm essentially not adding or subtracting anything from the function. And the value that goes in the blank is b over 2 squared. And again, it's going to go in each blank because I need to make sure that whatever I do in one, I do in the other. So it's a little bit confusing looking at A, B, and C. Instead, let's take a look at how this actually works with numbers. So here's what I want to do. I have a question that says integrate using the completing the square method. And they're not usually going to tell you to use completing the square, but what I know is that this is not a perfect square as it is. Because if I tried to factor this, and I can only really use 5 and 2, I can't use minus 5 minus 2. That gives me minus 7 in the middle. That doesn't work. So essentially what I want to do is I want to take this and be able to write it as x minus something squared and then plus whatever is left over. So let's look at how we're going to do that. I'm going to take my x squared minus 6x plus blank, and then I'm going to leave the plus 10 on the outside, but then I'm going to minus the same blank. And notice I already have it worked out down here, but I want to work through it with you. Well, my b value is negative 6. So I'm going to take negative 6 divided by 2 and square it, which gives me negative 3 squared, which gives me 9. So I'm going to put a plus 9 here and a minus 9 here, which means I can rewrite this as x minus 3 quantity squared plus 1. So let's talk about where those came from. The plus 10 minus 9 gave me plus 1. This is now a perfect square, which is of course why we call it completing the square. And the number that I'm going to use is always b over 2. So b over 2 was negative 6 over 2, which was negative 3. That's the number that went here. And again, I can always check that by then writing x minus 3, and foiling it back out, and notice that I will, in fact, get that. But I don't need to do that because I'm so good at math, I know I didn't make a mistake, right? So notice what I've done is I've now rewritten my integral as dx over x minus 3 quantity squared plus 1. So I just rewrote it after I completed the square. Then it says make the resulting binomial your u value, which means this guy is u. So u is x minus 3, because again we're taking the square root of that, right? And then we're taking the square root of this to get a, so the square root of 1 is 1. And then the derivative of x minus 3 is just 1 dx. And now, if you'll notice, it fits one of my patterns, which is why we would complete the square, because we want it to be a perfect square. And now I'm using that antiderivative pattern that says if I integrate 1 over u squared plus a squared du, I'm going to use the arctangent pattern, and that tells me to do this. And that is my final solution. Here is a completing the square question for you to try on your own. So again, take that denominator and complete the square, and then continue to integrate the function. When you're done, press play to see how you did. So again, what I'm going to do is I'm going to start with x squared minus 4x plus blank. It's always plus on the inside. Then I'm going to keep my plus 7 and then minus blank on the outside. Remember, inside the blank is b over 2 squared. So b is negative 4. So negative 4 over 2 squared, which is negative 2 squared, which is 4. So 4 goes here and 4 goes here. And what does that simplify into? Well, this guy turns into x minus 2 quantity squared. And then, of course, plus 4 and minus 7 gives me plus 3. So I'm essentially rewriting this into dx over x minus 2 quantity squared plus 3. From here, I'm going to start assigning what u is and what a is. So again, this is how far we've gotten so far. I'm taking the square root of this and calling it u, so x minus 2. The derivative of that is just 1 dx. Taking the square root of 3 and calling it a, so radical 3. Then I'm saying what pattern does it fit? This fits the arctangent pattern. The arctangent pattern says plug things in according to this method, and that is what I do, and that is my final solution.